Hello, welcome back to Cracking the Cryptic and a recommendation off our Discord server, a puzzle that hasn't been there very long. Now, this is a sort of P-line puzzle with a slight twist. Those have been pioneered by Samu Piano especially, but this one is by Sudoku and Chinstrap, who've been collaborating lately, and they've come up with a variant of it. I'm looking forward to giving this a go because I like the rule set. It's quite interesting. It's not complicated. Look how short the rule set is, and that even includes an example. So it really is quite simple to understand. That's always a good thing, and we get a lot of new people every day, and we hope that they stick with variant Sudoku. If you're one of those, watch the solve to this puzzle or give it a go yourself and learn how enjoyable variant Sudoku can be, because that's what we think. We put out 2 videos a day of it and have been doing for years and years, so that we definitely think that. Now, what have we got going on? Well, we'll get to that in a moment. What have we got going on the channel? We've got Are You My Mama, the PBN Institute's Fabulous Number Sums Sudoku Hunt on Patreon. It's a competition till the 20th, then it'll just sit there and you can have a go at it. 11 puzzles, all of them paint a picture, which is part of the great fun that the PBN Institute achieve, and it's well worth a try. Give it some of your time because it's a fabulous collection. There's always extra content on Patreon. At some point this month I'll be doing a very hard crossword from the Times Monthly Club special. There are connections videos and more Sudoku than you could shake a stick at. Loads of Sudoku in our apps, of course, which do include line Sudoku and are very good fun as well. Do check those out. There's our merchandise, there's SVEN'S SUDOKU PAD on the links under the video, and of course said Discord server from which this puzzle comes. Now, I'm going to just do the rules now. Normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box. Digits on a line sum up to a 2-digit number made out of the digit in the line's circle repeated twice. Now what does that mean? It says, for example, 2, 4, 5 on a line, like this one. You could put 2, 4, 5 on that line. They sum up to 11, which is a number that features a repeat digit, and therefore this circle would contain 1. So basically, the circles contain both the tens digit and the units digit of the number that is the sum of the digits on the line. It's a very simple rule. Give this puzzle a try on that first link under the video. I'm just going to get straight in and start now. Let's get cracking. So let's start with that 3-cell line and a couple of other 3-cell lines. Might as well colour them. Now, a 3-cell, in the instances that I've highlighted, I don't think I've missed any 3-cell lines, but in all of these yellow instances, each of the digits on the line sees the other ones, so they all have to be different. Now, obviously the absolute minimum that 3 cells that are different can add up to is 6, 1 plus 2 plus 3. The maximum is 24, 9 plus 8 plus 7. That means that the total, which is in each case a number that is divisible by 11 because it's got a repeat digit in, is either 11 or 22. So those cells are occupied by 1 or 2. This is a 1-2 pair. Right, I've got 2 conflicting thoughts going on. One is that I think I know what this is, but the other is that I think these have to be different. Now that's just something to explore here. These 6 digits in box 3 that are now handily yellow, if these were both 1s, they would add up to 11 plus 11 is 22. They would have to be 1, 2, 3, 4, 5, and 7. Adding up to 22. That's the only 6-digit combination that adds up to 22. And you could split those up as 7, 3, 1 and 2, 4, 5, but then you would have to make this 6, 8 or 9, making the total of its line at least 66. Well, I'm afraid that is absurd for a line with only 5 cells on. It's impossible. So these are not 2 1s. If they were 2 2s, each of these segments would add to 22 and the pair of them would add to 44. That cannot be done with 6 cells. 39 is the maximum. It's way off. So this is a 1 and a 2. And I think that's probably telling me that this is a 3 in the corner. Now, the other thing that was warring in my mind is because of the 1 and the 2 that now appear as a pair in row 4, I don't think this can be a 1 anymore, because any 3 digits that add up to 11 must have either a 1 or a 2. Yes, you can prove that by thinking of what is the lowest it could be without a 1 and a 2. It's 3 plus 4 plus 5, that's 12. So this could never be a 1. So that's a 2. This is a 1. Because of what I just discovered about box jobby, these can't both be 11s, and that's a 2. And both 1 and 2 now see this circle. Now, can I prove this line can't add up to 44? Yes, easily. These 3 have to be different because they're in the same row. The maximum they can add up to is 24, plus another couple of 9s, if you could find a way to fit them in, would only get you to 33, 42. So this could never be 44, and this is a 3, and we can have a little party for 3 in the corner. That's 3 in the corner. And this line adds up to 33 now, and we know what these 2 digits add up to because the yellows in this box add up to 11 plus 22, that's 33. The 3 takes the total up to 36. And we know a secret about the total of every box. Just like every row and column, they contain 1 to 9 and always add up to 45. Therefore, these 2 digits add up to 9. I'm going to give them another colour, purple. The 2 purple digits add up to 9, but the whole of this line they're on adds up to 33. So these remaining digits on the line add up to 24. Now, I'm very tempted to go, oh, that's a 9, 8 and 7. Because they do add to 24 and are in 3 digits. But you have to be very careful here. These 2 digits could be a repeat. So if they were repeat 9, that might be a 6. They couldn't be a repeat 8, because that would have to be another 8. And they couldn't be a repeat 7, because that would have to be a 10. Right, I'm now going to rule out this possibility that I just thought of those being a 9 and that being a 6, by considering this line, which adds up to 22 because of the 2 in the P. 22 in 3 cells, that needs a 9. This is either 985 or 976. And now this cell can't be a 9. And now that 969 possibility is gone. And all of the repeat digit possibilities don't work. So in fact, these 3 are different digits. They are 9, 8 and 7. This cell is not 9 because of this line. And indeed, this yellow line needs either an 8 or a 7 on it. It's either 985 or 976. So between these 4 cells, we've used up 9, 8 and 7. That means other digits in the row that aren't 1 or 2 are 3, 4, 5 or 6. I don't know what else that means, but we're making good progress here, I feel. Okay, I'm going to move on to which line? Oh, well, no, let's have a look at this first. Or this, I don't know which. This has got a 9 on it, same reason that one does. It's 985 or 976. This one adds up to 11. And it doesn't have a 3 on it. I suspect there are only 3 ways of making it up. 128, 146 and 245. My guess, the sort of educated guess, was right. But that doesn't actually inform me. Well, I don't know. If it was 128, this would be a 4-5 pair adding to 9. If it was 146, this would be a 2-7 pair. If it was 245, this couldn't add to 9. Oh, that's interesting. If this was 245, 2, 7, 3, 6, 4, 5. Oh no, this would be a 1, 8 pair. It does work. Oh, bother. So I can't decide what's on that 3 cell line. Okay, I am going to look at this one. I was planning to, then I put it off for a bit. Now, the digits I've written in here make this add up to 33, 44, 55, or 66. At least one of those is absurd. The maximum this can add up to is, well, I would normally say 9876 in those cells, but look here. 2 of the big ones are gone. So let's say 9654 in those cells as an absolute maximum, which is 24. And then 2 high digits here, which again can't use more than one of the very high digits, 9, 8, and 7. So 9, 6 there to go with 24 here. 39 is the maximum. So that is a 3 straight into the P there. Our second 33P. Now, what did I say was the maximum? 96, I've forgotten already. 9654 is 24 and 15 there is 39. So there are 6 degrees of freedom, which is quite a few. Oh, here was a much... No, it wasn't. No, I didn't know that 3 wasn't in those cells earlier. I was going to say where else could 3 go in the line, but those 2 were candidates before, so I should pipe down. Okay, should I look at this? Or should I try and work out the 33 a bit better? I'm not sure. I'm not sure what the best thing to do next is. Oh, the best thing to do next is this P, which now cannot be 22 or 33. I don't think it can be as high as 44. Let's say that was a 9-8 pair, and that was a 9-8 pair. That's 34, plus a 9 there. Wow, I mean, the maximum when you just count it in rows is 33. No, 43. 9, 8, 9, 8, and a 9. I suspect that maximum is 1 lower if you go 9, 8, 7, 9, 9, counting it in columns, or in boxes, it's much the same. 42. So this can never be a 4, and it can't be 3 or 2. This must be a 1. And we switch from 44 being a very high total for this line to 11 being a very low total for it. This digit, for instance, is already at least a 4 because of the box it's in. So let's put 4, 5, 11 on this line. 1, 2, 3, 1. 1, 2, 3 is the minimum for those 3, and a 1 for that. That's already 7. This is absolutely minimum, plus 4. There we go. 4 there, 1, 2, 3 here, and a definite 1 there. That rules 1 out of those cells, puts it in there. 4, 5, 6, 9, 11. This is going to be right. So this line's been a bit of a giveaway when I figured out that it was worth looking at. And we get a load of 1s in the grid. I can write a 1 in column 6 there. That doesn't tell me where the 1 is in this box. Yes, it almost does. 1 can't be on the 22 line. And now it's been ruled out of those cells by Sudoku, so it's left to be in one of those 2. So it's close. Then 1 in row 1 is in one of those 2 cells. Now, what about this? Right, if it can't be as many as 55 on this line, this is a 2, because it sees 1, 3, and 4. Now, can this line be 22? Can it be 55? Could it even be 66? Theoretically, 987 there is 24, 987 there is 24, 987 there is 24, and a 9 here. That's a minimum of 81. A maximum, sorry. A maximum of 81, but I don't think that is actually the maximum. Let's think about it a different way. 98765 in the bottom row is 35. Then a 9-8 pair here and a 9-8 pair here. That takes us up to 69, and another 9 here. 78. Well, I'm surprised, but I have to admit 7 is just possible from what I can tell. Ah, this one's better, because look, this sees 1 and a 2, 3 pair. 44 is the maximum number I could write in there. Okay, let's split this line up into 4 digits there. Maximizing at 9876 is 30. 9, 9, that's 48, and a 9-8 pair. 65. Oh, well, okay, that didn't quite get to 66. This is 4 or 5. I'd hope to do a bit better than that. I've been a little surprised how the numbers don't narrow down as quickly as I expect. But I suppose when you get up to lines of length 6, or indeed this one's actually 8, I don't think I'd even realised that. There are quite a lot of cells and quite a lot of variety amongst those cells. So, could this be a 2? Could this be 22? 15 there, 1, 2, 3, 4, 5. This is now a 2-3 pair at the minimum. That's 20. 23, 28 is the minimum. 2 is not possible, and was nowhere near possible. It's really shameful how I can't tell what is possible and what is very unlikely. Whatever that digit is, 2 or 3 goes in one of those cells. Oh, I don't know. Where do I go next? We've got a 9 definitely in one of these two. Right, so the maximum here, and let's say 9 and 7 at a minimum for those 2 cells. So the maximum for these, 8, 6, 5, 4. That adds up to 23. So the minimum for these 2 is 10. And this digit isn't allowed to be 1, 2, or 3. Minimum is not actually that exciting. What I need to know is the maximum, but that's not going to be so interesting. You can't have a 1 in this row, but you could have 2, 3, 4, 5, that's 14. 19's the maximum. No, barking up the wrong tree again. It's funny, this line was absolutely easy. This line I don't know what to do with. It can't have a 4 on this line because 9, 4 would require another 9. So the 4 in the row is definitely in one of those 2. So this line doesn't have, 4 there, 4 in one of those 2. That's a 4 by Sudoku. And this line doesn't have a 4 on it. Nine, I don't know. No, I don't know. Oh, yes, I do know that. No, I was going to say there's a 7, 8 pair within those cells. I don't know that. Not true. Right, I'm going to have to find something else to move forward with. 985 or 976. Now, this was going to be 146 or 128 or 245. I just don't know. Sorry, I do want to come up with something clever to help explain how to solve this puzzle, but I don't know what it is yet. That digit is going to be in one of those 2 cells. $33 on this line, so actually these, I don't know, there isn't really a low that I can get stuck into. This line, 55 or 66 or 77. 98765 here would be 35. Plus 9-8 pairs in both boxes gets us to 69. That's such a leap up, and a 9 there gets us to 78. Well, maybe I can rule out 77 because there's almost no margin for error there. If that's a 7, that's 9 or 8. This is 98765 or 98764. These have to be 9-8 pairs, or maybe with a 7 mixed in. I don't know, no, maybe I can't quite rule that out. That is very surprising. But I can't. Okay, fair enough. I'm going to have to do something else to make progress. Don't know what it is yet. You shout it at the screen if you know what to do. I do not. Okay, let's go back to this line, just in case. It seemed to have a lot of possibilities to me, but we're aiming at 44 or 55. And those four, I claimed they could be 9876. I mean, maybe that's shaded down by the possibilities here. We might think of where can you put 1, 2, and 3 in this column, and it's quite an interesting question. One of them can go there, neither of them can go on this line, none of them can go there. So although you could put 1 here, I'm beginning gradually to wonder if we have to take these 2 lines together, but I doubt it, you know, I doubt it. I'm not getting on brilliantly now. I don't quite know what it is I'm meant to be focusing on to get going again. It's tricky, this. Okay, can 2... This is quite an interesting question. Can 2 be on this line? The highest digits available are 965. If they went with a 2 on the line, that would be 22. These two would have to add up to 11. No, that is very doable. Oh, 3. 3 is just placed in box 2. There it is. Blindingly obvious. Right, if that's what you're shouting at the screen, I heard you. Because of the 2-3 pair there, that's ruled 3 out of all of those cells, given the 3 in the corner. So now 3 is now twice on this line suddenly. And that's a lower digit than we were led to expect in a way. So this is now 9653 plus 9 plus 3 at an absolute maximum. 9653 adds up to 23. Plus 9 plus 3 is only 35. There are very few degrees of freedom left. 2 degrees of freedom between 35 and 33. Let me just check that again. 9 as the high digit, not in those. 653, because we need the 3. That's 23. Plus 3 is 26. This is at least 7. So now this is a 789 triple, and this digit is not 789 or 1, 2, 3. It's middly, 4, 5, or 6. I'm not going to start redoing colouring and making that yellow. These are both from 4, 5, 6 in the box as well. Oh, that was so interesting. Right, now, does 9 have to be on this line? No, because 8... no, wait. One of these 3 had to be 9. This is a 987 combination. So one of those 2 is 9, and that's not, and these aren't. So now the biggest we can have here is 8653. I think we're using up both degrees of freedom at once. 8653, not a combo that I've added up a lot in the past, adds to 22, plus 8 plus 3 there, which is now the maximum, is 33. There we go. We did use up all the degrees of freedom. So this is 8653. That one can't be a 4. This group is the one that I'm talking about being 8653. With that 83 there makes this blue line add up to 33. Now 8 has come out of those cells, 7, 9, and goes into that one because this had become a triple. This becomes 976 because it can't have an 8 in. 6 comes out of those cells. In this row, we've had 3, 5, 6, 8, and 7, 9. These digits are 1, 2, and 4. That one is a 2 or a 4. Now, this was going to be either 1, 4, 6, in which case that would be a 6. 1, 2, 8. That's now impossible as none of those cells can be 8. Or 2, 4, 5, in which case this is a 5. One of these is definitely a 4, and that isn't. These 2 cells add up to 9. The purple cells, remember. Well, they can't be 1, 8, because that'll break. So that's a 2, That's a 7. This is 4, that's 1, that's 6 to make the total work. 985 is what we get here. And we write it in as 985 like that. This one can't be 8. Right, that's good. That's really progress. Now, where are we going to apply that? It doesn't lead into many of the other lines naturally. However, there is now a 5 in one of these cells, and that's stopped this being 55. And look, that 6 has stopped it being 66. 77 is very constrained, but it's happening. So hang on, just a bit of Sudoku first. 7's in one of those two cells, not there. Sorry if you can hear some beeping. I can too. Now, let's look at this 77. So those 35 maximum, then a 9-8 pair here and a 9-8 pair here takes us up to 69 maximum, and a 9 here is 78 maximum. There is 1 degree of freedom. That is 9 or 8. These two include a 9 and either 8 or 7. These two include a 9 and either 8 or 7. And you could say the same about that pair and that pair. There are definitely 2 9s in those cells. That's an X-wing that puts 9 in one of those cells. And these are either 98765, or we can take 1 off that and make them 98764. Never afraid to over pencil mark. Well, I am a bit, but I'm not too bothered this time. Now, this group of cells in column 7 has a 1 on. I know exactly where that goes, there, and a 3 on somewhere. And I don't know where that goes, but this is limiting this digit, isn't it? So, maximum now on this line, 9831 there. Well, it couldn't be that. Let's say 9731, which adds up to 20. Then I'll allow 2 9s there. That's 38. Oh, okay, if I have a 9 there, this can't be 9 or 8. And now I can't make this 17, which is what I would need to get that to 55. So that is 44. And that missed it just by 1 skin of a pea. That's the phrase I'm looking for. That's a 4 in box 2. This is a 5-6 pair, so that's not a 6. And indeed, this one is 7 or 9 now as well. I think it'll be a while before I get to sort out these cells in the red, but still, worth trying. These are from 5, 6, 9. Oh, if they had a 9 in them, that would make this an 8. That would take away all the degrees of freedom. This can't be 4. Wow, if this was 98764, that would be the 4. Oh, let's look down the final column. We've got 2, 5, 8, and 9 to place. This one is seeing 9, 8, 7, and 6 in the row. They must be in this row. That's quite interesting in a number of cells in the row. Actually, I'm doing a bit of pencil marking here. This one is left to be 2 or 5. And I was trying to think about this column. I've got a 2 or a 5 there, 8 or 9 there, and 2 more of those digits to put in. This one can't be a 5 because of that pair. It's not quite done though. So the blue line is done. All of the yellow lines are done. This one, which I never coloured, is done. So it's only red and what I'm now going to call green that we have left to do. And this is 44. Now that seemed to have degrees of freedom, unfortunately. We can't put a 9 in those cells. I hadn't noticed that before because these include either 9-8 or 9-7. So the absolute maximum for these two, and I have a feeling it wouldn't even work, is an 8-6 pair. So 14 there. What was I saying up this column? 9731. That's worth 20. So we're up to 34. These two have to add to at least 10. It's not that helpful. Rather as I feared. Right, 2 is in one of those cells. 3 is in one of these two in the box. 3 was in one of these 3 as well. Oh, 7 and 5 are in this group of cells, aren't they? That's not very helpful. Oh, that's the only place for 1 in the bottom row. Hadn't seen that coming. That places 1 there in the top row. 7 is in one of those 2 digits. I mean, it was helpful making it not 55, but getting it to 44 has left me kind of a bit nonplussed about where I go from there. Oh, look, 4 in box 7 is quite constrained. It can't be in any of those cells. So 4 is definitely in one of those 2 in box 7. And then it's definitely placed there in column 1. And these are from 2, 5, 9. That one can't be 2. So the 2 in row 2 is placed. There it is. Now that's the 2 in column 1. That's the 2, unsurprisingly, in box 8. Not on the green line is what I'm unsurprised by. One of these 2 is definitely a 2 now. Okay, well that was something going on. 1, 2, 3, 4. Goodness, this can't be 8. Oh, this can't be 7. That's a definite 9-8 pair, so that's not where the degree of freedom is going on the red line. That being a 9-8 pair means this isn't an 8. That's interesting. Right, a 9-8 pair in the box and a 1. 7 is in one of those 2 cells. Ah, this is 2 or 5. It sees 9-8 in the box, 3, 6, 4, 1, 7 in the column. That's 2 or 5. And that's a pair in this column. That makes this 8 or 9. And that is slightly reducing what these can be. Maybe I should do it in boxes now. I think the maximum you could put in here now is 9, 6, 3, which adds up to 18. Plus a 9 there is 27. 7 and 1 here is 35. These 2 have to add to at least 9, but they already add to at least 8. So that's unexciting, I'm afraid, yet again. Only one place for 2 in the bottom row. Good spot. You're right. There it is. That's a 5. In fact, that 2-5 pair was resolved by that. Now, a 5 here. Oh, I'm nearly able to say that 5 in the bottom row is definitely in red, which would have been quite telling for where the degree of freedom was going to go. But it didn't do that job. I'm going to have to do it myself. There's an 8 in one of those 2. So that's not 8. Could have just done that by looking at it. Oh, come on, Mark. Come on, come on, come on. What's going on? Still think it's about this green line. Now, 8, 9, 5, 2, 1. That can't be 5 anymore. 3, 4, 6, 7. To place in box 9. 2, 1, 2, 1, 2, 1. 3. No, I don't know. I don't know what's going on. Plaintive cries from this area. Right. Deadly pattern? No. Not. Can't use uniqueness. Right. There's a 7 somewhere there. If I could rule 7 out of there, I could rule it out of those cells, which I suspect is what I'm going to be doing. But it's only a suspicion at the moment. It's not fact. I've got to keep working on this 44. Right, maybe I need to think about these 2, which can't use 9 and only one of 8 or 7. So the maximum they can be is an 8-6 pair. Now, I have a feeling that would falter. That would make this 5, 7, 9. 8 there and 6 there. Okay, no, it wouldn't. So 14 is the max here. Plus the 1 there is 15. This line does add up to 44. And 4, 5, 1, 7. It's got a 3 somewhere. Yeah, this column. What's going on in this column? 14, the max there. What's the max here? If that was 5, 8, and that was a 4. Oh no. If that was 5, 8, that could be 4 and that could be 6. 3, 7, 9 is the maximum. So that again was 20 for that bit, 14 for that bit, that's 34. I've done this exact calculation before and worked out that those two have a minimum between them of 10. Well, okay, that stops this. I know I was going to say it stops this being a 2, but that's not quite true. If this was a 2, that could be a 9. We've got 1 degree of freedom over the rest of the calculation. Now, let's have a look at this column again. 2, 1, and 4 have gone. 3 is in one of those cells. Now, if 3 was here, are we busting this line? Let's allow that to be 8, 3. That's 11. And 20 there. That's 31. No, it's fine. I can't falsify that. Wow, I'm sorry, I'm not really finding the way through here. Maybe there's some colouring to do or something very peculiar like that still to achieve. That digit, for instance, is the same as that one. I don't know what that means. The 44 line is not helpful. The red line I thought was going to be incredibly helpful. It really isn't. Okay, maybe the minimum for these two, I'm sure one of these is a 9, but have I proved that? No. That is 8 or 9. This is either a 9-8 pair or a 9-7 pair. It's just possible for that to be 8-7 as far as I can see so far. I suspect there's something that rules it out. I don't know what that is. Okay, is 2, can I rule 2 out of this, out of that cell? 2 already can't be in those. It's in one of these two. That's just Sudoku. Can I rule it out of here? Even that would be worth something. If that was a 2, oh, I tried this earlier, I didn't really get there. If that was a 2, I was going to say 3 would be in one of these. That's not necessarily true. 3 could be there. If that was a 2, that was going to have to be a 9. Then surely we've got to put 9 on this line. Ah, that's worth thinking about. If we don't put 9 on this line, if 9 is in one of those two, this could be 8, 7, 3, 1, which is 19. I'm not there. I haven't got the degrees of freedom to play around with that I'm expecting. 2, 4, 5, 1. So maybe I add up both of these lines together. If I put a 3 here, then I've got 6, 7, 8, 9 for the lines in row 8, which is 30. I could have 35 in the bottom row, that's 65. That 1 takes it up to 66. Now in this row, wow, I mean I could have 9, 8, 7. I'm not narrowing things down at all. But let's just keep going, just in case. So 35 there, max. What did I say here? Everything but 2, 3, 4, 5. So 31 max. That's 66. 9, 8, 7 there. Another 24 takes us to 90. 9, 8, 6 here maybe. This is not the way to do it. That's just massive. 113, and I'm only looking for 77 and 44, which is 121. I'm very nearly there. No, that's no good. Oh, this is funny. Why am I being so slow today? One of those is definitely a 3 in the bottom row. If the other one is a 5, the degree of freedom goes here. That has to be 9, that's 9, that's 9. That can't happen for the interesting reason that if that was 9 and that was 9... Oh, this is very interesting. Right, I think this applies throughout. If this is a 9, this is where 9 is in box 7, which needs a 9 in one of those cells. Then this is where 9 is in box 9. Now, that cell becomes 8. And if that's a 9 and that's an 8, there's no F for 8 in box 4. That is complicated, fair, and brilliant. This is not a 9, and there goes the degree of freedom in red. Everything else has to be maxed. That's an 8, that's a 9-8 pair, so is that. This is 9-8, 7, 6, 5. So I'm getting rid of the 4 possibility there. It's not much, but also these two are a 3-4 pair now. Now, that 8 has made this 9-8 in an order we can determine, and this 9-8 in a similar order we can determine. We get a 9 there, and now we know that 9, where that goes in box 4 instead. Oh, it's sort of weird interplay between those cells and where that went in box 4. That's so strange. It's very cleverly done, I must say. 7 and... No, hang on. I'm mismarking these cells. This is a 6-7 pair. There's no 6 in these cells. These are from 2, 3, 6, which are quite low digits. In fact, we've lost 9 off this line entirely. That's going to be interesting in a moment. I don't even know the order to attack this, but I think we're going to get there now. That's not an 8. 5, 6, and 7 still to place, in both in column 1 and in box 4. 5, 6, 7 triple there. 1, 4. These do include an 8, and either 2 or 3. Now, if that was 8, 3, 2, that would be 13. Oh, this pair has now got narrowed down to a maximum 13 as well. So 13, I'm imagining there if we didn't use 8 and 6. 13 here, that's 26, plus 1 there is 27. You can't get to 44 because you can't make those two add up to 17. So this is not 8, 3, 2. We need both 8, which is in one of those cells, and 6, which must be here. And that's now not a 6. And now let's do it again. There's definitely an 8 in one of those two. So 8 plus 6 is 14, plus that 1 is 15. Then there's a 2 or a 3, a 5 or a 9, a 3, 4 or a 7. What did I have us at? 14, 15 only. With 29 more to go. I don't know, this is getting very complicated in my head. I can't do it. 1, 2, 9, 4. We need 8 in column 3. Let's do ordinary Sudoku. That's there. These are from 3, 5, 6, 7. And the 3 in the column is in one of those two cells. So that's a 4. That's 3. These are not 3s. Especially that one. But the 3 in column 7 is now placed there. This must be 8, which had to be on the line. That's a 2. 4 is in one of those cells. Well, I should have known it's not there from this. Now, back to the green line. We've got 17, 18 already now. Maximum 6, 7 here takes us to 31. And then we would need 13 more. Well, it's not exactly that. Oh yes, 9 and 4 would do that. So it is possible that it's exactly 6, 7. If it's not, if this was a 3, in fact that is 6 or 7. If this was a 3, Then we've got 17, 18, 21. We need another 23. 7, 7, 9 will do it. It can still be a 3. That's so irritating. Okay, how about this 5, 6, 7, 8, 9 malarkey? 8 and 9 are definitely in this group of cells. Oh, we know exactly where the 8 is in the bottom row. It's there. 9 is in one of those two. But look, there's a 9 X-wing. So 9 is not here. It's definitely here. Now, going up this column, that is a 7 because of the 5, 6 pair. That 6 makes this a 7. Now, in certain digits in green, which I'm just recalculating again and again and again, we're on 25. We need another 19 between these three. If that was a 6, this is 9, 4. But if this is a 3, this is 9 sevenths. This is always a 9. Good grief. Wow. Okay, this is not 7. These are 3, 5, 6 in some order. And these two add up to 10. And I've got two ways of doing that at the moment. I'm going to remove all the colours from everywhere. I've done every bloomin' arrow, apart from these two, which have to add up to 10. That's the only thing I've got to make happen in the puzzle that hasn't already kind of been made to happen, I think. Now, 9 and 8 are looking up at the top, so that's a 5. That's fixing a lot of things in the top 2 rows. A lot of things. They're all just getting done. Yeah, that is the top 3 rows all complete, and indeed row 4. And that column, this 5, 6, 7 triple, I can do the 5, I can't do the other 2. Wow, that just fell apart like a beautifully cooked piece of meat. Right, 4, 6, 7 there, 9, 1, 2, 8. This is a 3, 5 pair now. That should be, I'm literally going to have to come down to this and figure it out now. So one of these is wrong. If that was a 3, 7 pair, oh, here it goes. Where would... Oh, no. Look, I've got a 6 looking at that cell. Yeah. Sorry, I don't need to do all of the what ifs. I just need to do Sudoku and finish it off. 4 there meant this was a 6. That's what those greens were doing. And that does finish it off. Oh, it does if I stop typing in colours. Right, 5, 3, 6 there. 5 and 3, and that is the solution to P-pods. Brilliant. No wonder 87 people have done it in the first 4.5 days, because it's blooming brilliant. That's great fun. Lovely puzzle. Definitely a nice, smooth start, and then you had to really do some thinking, although when I finally got my head around which things mattered and a bit of Sudoku, it came together beautifully. Lovely puzzle. Thank you for watching us on the channel as always. A pleasure to have you with us, and I hope to see you again tomorrow. Bye for now.